Alright, we're going to talk about changes of heat involved in changes of state. You'll remember from one of the gizmos where it showed you ended up having it to where it stayed flat during your phase changes. We're going to address that and do the calculations, but let's talk about what these are. Heat of fusion is when something is melting. Solidification, becoming a solid. These numbers are the same number, but solidification means that it's a negative number. But it'd be, so if fusion is 601, then solidification is negative 601. It's the same number, same process. Vaporization, hopefully you can figure out that's when it's vaporizing. And heat of condensation is when it's condensing. So those are your different phase changes in what they are called.
Alright, here's how we use them with our graph. Here's our graph, and then here's our sample question. How much heat in kilojoules is absorbed when 40 grams of ice at negative 50 degrees Celsius becomes steam at 140 degrees Celsius? So that's mapped out by this graph here. You start out way down here at negative 50 when we have ice, and so we go all the way up to 140 in steam. So if you notice the areas where it's at a diagonal, we have a solid, liquid, and a gas. And the areas that are flat are the areas that a phase change is occurring. So you're going from a solid to a liquid, so you're melting. Then from a liquid to a gas, we are vaporizing. And we're going to calculate each one of these lines using the formulas that are on there.
Okay, so the first part, we are calculating how much it takes for the ice to get to the melting point. So we use the Q equals MC delta T. The 40 grams is from that. The 2.1 is your C for ice.
It's different from just water.
And you'll always be provided the constants, unless we're asking you to solve for a constant. And then the temperature change is it has to go from a negative 50 to 0 degrees Celsius, because that's when it starts melting, as you may recall. So I plugged that all in, and it's 4,200 when you calculate out. We want our final answer in kilojoules, so I took my decimal and moved it 3 places to give us 4.2 kilojoules.
Alright, the next section is actually during a phase change. So we're going to use the grams of ice that we have. We have 40 grams of ice, but we need to change that to moles. So we're going to divide by the molar mass of ice, H2O. We have 2 H's, 1 O. And then we're going to multiply it by the delta H of fusion.
Which again, you'll always be given these numbers. You don't have to memorize constants.
So we multiply across the top, divide by what's on the bottom. It's going to take 13.34 kilojoules to do this phase change,
which is the melting. Okay, the next part on the diagonal, when we're going from 0 up to 100, when we reach the next phase change for water. Again, the 40 grams of ice. The 4.184 is your C of water. And it's going from 0 degrees to 100 degrees. And so that's where my temperature change came from. Multiplied across that. Remember, this gives you joules, so you always have to convert. For these type of calculations, you have to move it to kilojoules. And that's where we got the 16.736.
Next phase change, we're going to go from a solid to a liquid. So that's the flat part right here, and that's vaporization. We still have 40 grams of now water, so we need to change that to moles. So we divide by the molar mass again. And then we're going to multiply it by the delta H of vaporization, which I just looked up. And we're going to give you that. So we multiply across the top, divide by what's on the bottom. It takes 90.34 kilojoules to vaporize it.
Okay, the last little bit up here while we are in steam, we have our 40 grams, same 40 grams from up here from the problem. 1.7 is the C for steam. And then it's just a temperature change of 40 because once it's converted over, that's still at 100 degrees, and we're just going to 140, so 140 minus 100 is 40. Multiplied it across like we've been doing, converted it to kilojoules.
Attention, girl.
Alright, so then we multiplied it, and I moved it 3 places to get our 2.72 kilojoules, and then the final step,
add it all together. We're going to add every heat for every situation. So the first one, the phase change, the heat it up, the phase change, the next one, add it all together. That's how many kilojoules it takes to make ice at negative 50, all the way up to 140 degrees in steam.
Alright, that's it for this part of the unit, so you can go ahead and stop it. The next slides are actually for the next part. See y'all in class.